Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, Mathematics is Archimedes. We'll return to the great Archimedes with another mystery that has remarkable parallels to that of the Antikythera mechanism. See the episode Prime for that story. Most of the information in this episode comes from the excellent book, The Archimedes Codex by Netz and Noel, and the related PBS Nova show, Infinite Secrets. In 1907, the scholar Johann Ludwig Heiberg found a palimpsest in a library in Constantinople. The palimpsest was created in 1229 when a monk took a book, scrubbed off as much of the text as he could, turned the pages sideways, and wrote a book of prayers on top. Needing more paper, he did the same with other texts in his library. In doing so, he erased what was probably the last surviving copy of Archimedes' description of his techniques for solving mathematical problems, which he called the method. A couple of pages would have looked something like this, with the prayer book in red and Archimedes in black, but mostly erased and only very partially visible. Here's a close-up of the actual palimpsest. Archimedes' work is only very vaguely visible. By 1907, this work was legendary, known only by references to Archimedes the method in various texts following Archimedes' death in 212 BC. Heiberg could read some of the text that the monk had not completely erased and transcribed as much as he could. The discovery of a lost work of Archimedes was big news. Unfortunately, Heiberg's work was interrupted by World War I, and at the end of the war it was discovered that many of the library's holdings had been, quote-unquote, lost. By 1932, the book had found its way to a private owner in Paris, but its owner needed to sell it to get a ticket out before the Nazis invaded. The new owner kept it in a cellar where its condition deteriorated substantially. For years, it was an obscure possession of a family in Paris. But in the world of mathematics, it was considered to be a tragic loss, though Heiberg's work had recovered important details. It was known that Archimedes had come surprisingly close to inventing calculus in theory, but it was generally considered that the Greeks were not interested in practical applications like those calculus illuminates. One page of the palimpsest was found in 1971 in a Cambridge, England library by classics professor Nigel Wilson. In the Nova episode, Wilson recounts his discovery and notes, "It was a very good moment. I became rather excited." Whoa, steady on, man. Then in 1991, the French owners explored selling the palimpsest. It was initially valued at around $1 million. In fact, it brought $2 million at auction in 1998. The buyer remains anonymous, but remarkably and thankfully immediately loaned it to the Walters Art Museum in Baltimore for cleaning, imaging, and translation. What a gift to posterity. It did not look like a $2 million book, but a top-notch team was assembled to clean, image, and translate the text, and gradually recovered much of the original work. And some of the portions that Heiberg had not been able to see were spectacular. Before discussing these finds, let's take a quick break to discuss some of the challenges in translating the text. Not all of the letters came through clearly, plus the scribe who copied it nearly 1,000 years after Archimedes wrote it would have made mistakes. On top of that, Archimedes wrote in all capital letters with no spaces in between words. If a student wrote, "This is a Grimm talk," you might parse it as "this is a Greer talk," and since Greer makes little sense, you could conjecture that it originally said "this is a great talk" and had a typo. A real issue of this sort plays an important role in Archimedes' history. In a different, better preserved work of Archimedes, a scribe had written this, and since Phidias was a common name, it was split as Phidias Occupator. But Occupator is a nonsense collection of letters. The change of one letter in the original Greek gets you to this, change the K to an M. It now splits nicely into 4 Greek words that translate as Phidias, my father. This is the basis in which we believe that Archimedes' father was named Phidias. So, what was spectacular about the newly recovered Archimedes text? We get enough of his method to understand that Archimedes was doing calculus to find areas and volumes. He beat Newton by 1900 years, though to be fair, Newton's calculus was more fully developed. An existing Archimedes text had shown that he had computed the center of mass of a triangle. Leonardo da Vinci was impressed by this and challenged himself and was able to find the center of mass of a tetrahedron, a 3D figure consisting of 4 triangles. Well, in the method, Archimedes finds the center of mass for a paraboloid, a hyperboloid, an ellipsoid, a portion of a sphere, and other 3-dimensional curved figures. You thought Leonardo was good, huh? Not only did the palimpsest contain these results, it revealed how he did it. In his other books, only results were given, not his method. To show how Archimedes did it, let's go through his proof that the area under a parabola, shown in yellow here, is 2/3 of the area of the surrounding rectangle. So take the parabola with points A, B, C and construct the triangle AZC as shown. Draw a random line XM as shown and mark the point O where it intersects the parabola. Then extend the line CB so that the length of CK equals the length of KT. And also draw HS to be the same length as XO. Then we imagine a kind of seesaw pivoting at point K with weights SH on one end and XM on the other end. Archimedes shows that SH and XM balance. The infinity of XOs make up the parabola and are mirrored by the infinity of SH's on the other side of the lever. And all of the infinity of XM's make the triangle AZC. So AZC is balanced across K by the shifted parabola. Remember that Archimedes knew the center of mass of a triangle such as AZC. It's at the 1/3 mark on KC. So the parabola is 1/3 of AZC, and AZC can be shown to be twice the rectangle involved. AZ is 4 times dB. Archimedes was using arguments directly involving infinity and getting it right. Previously, we thought that the Greeks banished infinity as a way of keeping their mathematics unambiguous and precise. The pesky Zeno to the contrary. Only with Galileo and Newton did arguments involving infinity come to fruition. But Archimedes was there first, by nearly 2,000 years.